Welcome to our deep dive into the mysteries of Saturn, brought to you by the incredible data from NASA's Cassini mission. This spacecraft spent 13 years orbiting Saturn, sending back images and data that revolutionized our understanding of this gas giant. From its puzzling rotation to its enigmatic rings, Saturn is full of surprises. So buckle up, space fans, as we embark on a journey to explore the strange secrets that Cassini revealed, challenging our assumptions about how planets form and behave. Alright, let's kick things off with a cosmic head-scratcher: Saturn's rotation. Now, you'd think figuring out how long it takes a planet to spin on its axis would be a simple matter, right? Not so fast. Saturn is a gas giant, which means it doesn't have a solid surface like Earth. Instead, it's mostly swirling clouds of hydrogen and helium, making it tricky to track a fixed point and time its rotation. To make matters even more interesting, Saturn's rotation rate seems to change over time. Back in the 1980s, Voyager measured Saturn's day to be about 10 hours and 39 minutes. But when Cassini arrived, it clocked Saturn's rotation at around 10 hours and 45 minutes. That's a difference of 6 minutes. In the cosmic scheme of things, that's a significant discrepancy. It suggests that something is messing with Saturn's rotation, perhaps internal processes we don't fully understand, or even external influences like its moons or rings. Adding another layer to this cosmic conundrum is Saturn's magnetic field. Cassini's measurements showed that Saturn's magnetic field is surprisingly stable, which is unexpected if its rotation rate is indeed changing. Scientists are still trying to reconcile these observations, exploring theories about how a planet's rotation and magnetic field can behave so differently. Let's talk about magnetic fields for a moment, those invisible force fields surrounding planets, including our own Earth. They protect us from harmful radiation and help us navigate, but their origin and behavior are still not fully understood. Scientists have been studying them for decades, yet many mysteries remain. And when it comes to Saturn, its magnetic field throws us another curveball. Cassini's meticulous measurements revealed something astonishing. Saturn's magnetic field is almost perfectly symmetrical. Now, that might not sound strange at first, but in the realm of planetary magnetic fields, symmetry is weird. It's an anomaly that has puzzled scientists. Most planets, including Earth, have magnetic fields that are tilted relative to their axis of rotation. This tilt creates a magnetic dipole, kind of like a giant bar magnet embedded within the planet. But Saturn's magnetic field is almost perfectly aligned with its axis of rotation, creating a magnetic field that's eerily symmetrical. This perfect alignment is unlike anything we've seen before. This unexpected symmetry defies our current understanding of how planetary magnetic fields are generated. The prevailing theory, known as the dynamo theory, suggests that magnetic fields arise from the churning of electrically conductive fluids within a planet's core. But Saturn's symmetrical magnetic field throws a wrench into this theory. It challenges the very foundation of our understanding. If its magnetic field is generated by a dynamo in its core, as we believe it is, then why is there no tilt? What's keeping everything so perfectly aligned? These questions remain unanswered. Some suggest that there might be hidden internal structures within Saturn that are influencing its magnetic field, masking the expected tilt. These structures could be unlike anything we've ever encountered. Saturn's too-perfect magnetic field is a stark reminder that the universe is full of surprises, and sometimes, the most fundamental questions are the hardest to answer. The more we learn, the more we realize how much we still don't know. Let's be honest, when you think of Saturn, you think of those glorious rings, right? Those stunning, almost ethereal bands that make Saturn one of the most recognizable planets in our solar system. They're iconic, mesmerizing, and frankly, a little bit baffling. How can something so beautiful and delicate exist in the harsh environment of space? Saturn's rings are incredibly bright and pristine, made up mostly of ice with a smattering of rocky material. These icy particles reflect sunlight, giving the rings their brilliant shine. And that's where the mystery lies. How do these rings remain so clean and bright in the vast, dusty expanse of space? Space is a messy place, full of dust, debris, and micrometeoroids zipping around, constantly bombarding everything in their path. These tiny particles can cause significant wear and tear over time. Over time, this cosmic grime should darken and contaminate planetary rings, turning them into dull, dusty bands. Yet, Saturn's rings defy this expectation. But Saturn's rings, they're like the sparkling clean kitchen of the cosmos, seemingly untouched by the grime and dust that permeate space. It's as if they have a cosmic cleaning service. This pristine condition suggests that they're surprisingly young, perhaps only a few 100 million years old. In the grand timeline of the universe, that's incredibly recent. That's practically a blink of an eye in cosmic terms, especially when you consider that Saturn itself formed around 4.5 billion years ago. The rings are mere infants compared to the ancient planet. So, if Saturn's rings are relatively young, how did they form? What cataclysmic event could have given birth to these stunning structures? One possibility is that a moon or a comet got a little too close to Saturn and was ripped apart by the planet's immense gravity. This violent event could have created the rings. The resulting debris, shattered into countless icy particles, could have then settled into the rings we see today. This theory paints a dramatic picture of cosmic destruction and creation. Another theory suggests that the rings might be remnants of Saturn's formation, leftover material from the swirling cloud of gas and dust that gave birth to the planet itself. This idea connects the rings to the very origins of Saturn. However, this theory struggles to explain the rings' youthful appearance. If they were that old, they should be much darker and more contaminated. Some scientists believe that Saturn's moons, those tiny gravitational shepherds, play a crucial role in maintaining the ring's structure and preventing them from spreading out and dissipating into space. These moons might be the unsung heroes of the ring's existence. But even with these theories, there's still a lot we don't know about Saturn's rings. The mystery of their existence continues to captivate scientists and stargazers alike. Now let's journey to the top of Saturn, where things get even weirder. I'm talking about the hexagon. Yes, you heard that right. A hexagon-shaped jet stream swirling around Saturn's north pole. This isn't just some faint atmospheric anomaly. We're talking about a massive, six-sided jet stream, with each side stretching wider than the diameter of Earth. It's a storm unlike anything we've ever seen in our solar system. Imagine this: winds whipping around this hexagonal structure at over 300 kilometers per hour, a swirling vortex of clouds trapped within its geometric confines. But here's the thing that really boggles the mind. This hexagonal storm has been raging for decades, possibly even centuries. It's been observed by Voyager in the 1980s, Cassini during its mission, and even by telescopes here on Earth. What's even more perplexing is that this geometrically perfect storm persists, despite the fact that Saturn's North Pole experiences seasons just like Earth. On Earth, our jet streams meander, shift, and change with the seasons. But Saturn's hexagonal jet stream, it just keeps on swirling, seemingly impervious to the changing seasons and the turbulent nature of the planet's atmosphere. Some theories suggest that it might be a result of the unique properties of Saturn's atmosphere, particularly the interaction between different layers of gases at different temperatures. But despite our best efforts, the hexagon remains an enigma, a stark reminder that we still have much to learn about the complex dynamics of planetary atmospheres. Hold on tight, space fans, because we're about to delve into the heart of Saturn, where Cassini detected something truly bizarre, an internal wobble. Now, this isn't your everyday kind of wobble. It's not something you can see with the naked eye or even with a regular telescope. We're talking about subtle fluctuations in Saturn's gravitational field, a cosmic tremor that hints at something peculiar happening deep within the planet's core. These fluctuations are so minute that only a sophisticated spacecraft like Cassini could detect them. Gravity is a tricky beast. It's a force that governs the motion of planets, stars, and galaxies, yet it can be influenced by the tiniest of changes. It's not just about the mass of an object, it's also about how that mass is distributed. Even a slight shift in mass can cause noticeable changes in gravitational pull. So, when scientists noticed tiny variations in Saturn's gravitational pull on Cassini, they knew something was up. These variations were like a cosmic whisper, telling us that Saturn's interior was not as uniform as we once thought. These variations suggested that the distribution of mass within Saturn wasn't perfectly uniform, that something was causing an internal imbalance. This imbalance was enough to create a detectable wobble. Imagine it like this. Picture a spinning top that's slightly off balance. As it spins, it wobbles, its axis of rotation shifting slightly. As it spins, it wobbles, its axis of rotation shifting slightly. This is similar to what we believe is happening inside Saturn. Similarly, the internal wobble detected in Saturn's gravitational field suggests that something is causing a slight imbalance in the planet's mass distribution, leading to this subtle but detectable wobble. It's like the planet is trying to tell us a secret about its inner workings. One possibility is that Saturn's core isn't a solid rocky sphere like we once thought. Instead, it might be more complex and dynamic. Instead, it might be a fuzzy core, a diffuse region where heavier elements gradually mix with lighter elements further out. This mixing could create the gravitational anomalies we observe. This fuzzy core, with its less defined boundary, could contribute to the observed gravitational wobble. It's a fascinating possibility that challenges our previous understanding of gas giants. Another possibility is that there are deep atmospheric flows within Saturn that extend far below the visible cloud tops. These flows could be more complex than we ever imagined. These flows, driven by the planet's internal heat and rotation, could create variations in density and pressure that in turn influence the gravitational field. This dynamic interplay within Saturn's atmosphere adds another layer of mystery to this giant planet. As we conclude our journey through Saturn's strange secrets, it's clear that Cassini's discoveries have opened up more questions than answers. This magnificent planet, with its rings, moons, and bizarre atmospheric phenomena, continues to challenge our understanding of the cosmos. From its puzzling rotation and too-perfect magnetic field to its impossibly young rings and that mind-boggling hexagonal storm, Saturn is a treasure trove of cosmic mysteries. Thanks for watching, and don't forget to like, share, and subscribe for more space insights.